Hello everyone. In this video, I'm going to show you how to record the span of a peak along a particle profile. The purpose of doing this is because sometimes it's not enough to just know the location of the peak. We also need to know the width of the peak. And this is especially important in applications such as analyzing protein DNA complexes. If the protein is small, then we do not need to worry that much, right? The location of its peak would represent the location of the protein. But if the protein complex is huge, composed by like multiple proteins, such as this one, then the location of the peak only represents a tiny portion of the protein complex. And we do need to know the size of the proteins. In other words, the range of the peak where the DNA enters the protein and where it exits the protein. So we need to know the size and the width of the peak. Yes. So and that's important because now imagine if the protein binds to a specific sequence of the DNA, right? So we need to know. So simply knowing its peak location does not give us the accuracy where it binds on the DNA, right? If we can know the range of the section that it binds on the DNA, then we have more precision in knowing what sequence it binds to and what DNA structure it binds to, right? But if we just know the position of the peak, then that does not give us an accurate depiction of its location. So now in this example, we have the protein complex looping the DNA here, and already you can see that the entry point and the exit points are marked in this way. For example, the DNA goes from 1 to 2 to 3 to 4. That's one possible pathway that how it goes inside this protein complex. And 2 and 3, these two anchor points marks how it enters the protein and how it exits. And then it goes then from 5 to 6 to 7, and the points 6 and 7 represents how it re-enters the protein again, exits. And the trace profile is also segmented the same way as showing the main image. Now you can see the first peak is labeled in orange. That's from 2 to 3 in orange. And the second peak is labeled in purple. That's from 6 to 7 in purple. All right, let's see how to do that in Image Matrix. Let's first open up Region Inspector. Now this is the same molecule that we're looking at. So first, let's click the molecule to produce a trace. And let's drag the first point to one end of DNA. And then let's add another point in the midway. So by double clicking here, let's choose the path upwards and then double click here. All right. So once we have that, as you see, we have only 2 peaks. It's not passing through this protein complex. Let's add another point here to force it passing through this complex. Double click that. Now we have 3 peaks. Now the first 2 peaks are the same complex because it enters that and then re-enter it again. So in order to locate the peaks and its span, we need to use a profile called custom script, right, in this record custom. And there are multiple profiles listed here. If you cannot find them, you can click load profile. They are all under the scripts folder in the programs folder. And the profile we're going to use is called find peaks and spans. Now that's an extended version of the original profile called find peaks, which I already covered in another video. Now find peaks uses the prominence of the peaks to locate them. Now find peaks and spans, now we'll see what it does in a sec. Let's first click that. Now, as you see, we have them identified. There's 3 peaks, and we have 3 rows, and they're all their positions. And then we also recorded their span. So not only their position on the profile, right, but also their span left and span right. The span left means where it enters on the left side of the peak, and span right is where it ends on the right side of the peak. So in this case, span left and span will be the left side of this orange segment, and span right would be on the right edge of the segment. So let's see how how it looks in the actual image. So first, okay, so the first peak, it starts, the span starts from 2 to 3. So as you see exactly, it enters the protein at 2 and exits at 3. And the same goes for 6 and 7. So it does a pretty good job. And I think the same can be said about the second protein complex. And we can see that because it goes in and out in the same way. So that's, I think it's 10 and 8. And they cannot see them clearly because they overlap. So 9, I think is, I think it's at the, maybe it's 9, 10. I cannot see them clearly, but I think 9 probably is at the center of that. I think this is 8 and 10. That's this one. Maybe we can probably move this a little bit. That is 10. That's 8 and 10. This is 8. So it should be right. I mean, it should overlap at the same point because they use the same edge detection. So 8 and 10, they're both the entry point and the exit point, right? So yes, it identified the span correctly as well. So so it's doing great job in identifying the span of the peak. Now let's see what it does under the hood. So let's open the script. This is the find peaks and span script I'm using. So the first 3 parameters, we already seen that in the find peaks script. I already covered that in another video that uses the prominence of the peak to identify them. So we have about 1 nanometer of the prominence of the peak to identify the peak, and also we have this separation. But the only one parameter that's different from the original script is this one, it's the DNA cutoff. So that determines where do we want the segment, where would we want the span to start, where would we want it to end, right? So it needs to start when the height is above this 0.6 nanometer, right? And let's go back to the trace to see it better. So in this case, if you can see that, so that's like above 0.6 nanometer. Now if I can just make it bigger, let's see that. Maybe I can do this. Yes, so it's 0.6 nanometer, right? Above that, that's the cutoff I'm using, right? And anything below the 0.6 nanometer, and that's where it cuts off. Now, this points, that's the edge detection. There's only 2 points here. That's why I choose the previous point. So that's how it detects where the DNA cutoff is, right? Where it enters the peak and where it exits the peak. That's so you can specify that parameter so that to determine the range, the edge of your peak. Now you can also do that. So this one is basically like an automated process. We already specified its parameter. Now if you want to do that manually by specifying its parameters, you can basically click this one. This profile is called Find Peaks and Spans Interactive. Now if you click that, Now it gives you all the 4 parameters that you can choose. You can specify these parameters individually and then click OK. So, and you get the idea, it's the same profile, but now in this case, you can basically specify them manually. So a little bit more cumbersome. I usually just specify the parameters in the script because I would use the same profile for all my images. That usually works very good. So especially if the data is the same, taken from the same set of data, right? So, and that's why we just used find peaks. But the interactive version, you can use that to probe which parameter works best or not, right? So after you get the best parameters, then you can just write them down, and just put them down here in the script file, right? Then just use this profile instead. Now there's another profile called record peak and span. Now this is simply a manual version. So basically, once you first use one of the automated version, right? Find peaks and spans. And then if you feel like, okay, this is not doing so great. For example, if I try to zoom in this, I don't like this edge here. I want to move the edge a little bit outside, for example, like that. Yes, let's take this place. And then, okay, I feel like this is a better version of that, of the edge, right? And now what I can do is I can simply overwrite my original recordings. Let's get back my records table. So, okay, we have already recorded these 3 entries, right? Span left, span right. Now we want a different number, right? Because I have just removed the anchors a little bit, right? So I want to use my version of the span, right? So to do that, I simply choose at the start of the table, because I'm not going to write additional a new table. I'm just going to overwrite the original table. So then I'm clicking. If you don't choose the start of the table, it will simply add additional rows, right? So then I'm just right click the trace, record peaks and span. Then it will overwrite my original recordings. All right, that's pretty much for today's video. Thanks for watching, and I will see you next time.